All right, welcome back to another Tech Talk. This week we have James from IoTech who's going to be presenting on the Community DevKit that they've worked on for the project. If you were on the TSC meeting last Wednesday, he gave a very short demo of what he has done. And today we're going to go into a deeper dive about how all of the pieces work together and how you can use them to start prototyping your own IoT solutions using EdgeX as the platform. All right. With that, I will hand it over to you, James.
Okay, Michael, thanks a lot. Let me just share my screen. So hopefully you can see my slides now.
Yep, you're good.
Okay, let me just go to full screen mode. And I need to switch. Okay, yeah, so thanks a lot, Michael. So this is, I think, Tech Talk number 12, which is a deep dive into the DevKits. So quick look at the agenda. So we're going to cover what the EdgeX DevKits are. I think also important to spend a few minutes doing a reminder or an overview if people need it for what EdgeX actually is. And then I'm going to cover the first EdgeX Community DevKit, which as you'll see is a Raspberry Pi and Grove sensor-based kit. I'm also going to talk about the Grove device service we had to write for doing this. And I'm going to cover how to use it and an example scenario with a demonstration, and then time for questions and answers at the end. So let me first introduce myself. So my name is James Butcher. I'm a Senior Solutions Architect here at IoTech. We are part of the EdgeX Foundry. We're based in the UK, in the city of Newcastle. So as a Solutions Architect, I'm kind of primarily focused on usability and the kind of encouraging the adoption and rollout of the software. So there's my email address if you have any questions. So what are the EdgeX DevKits? So they're aimed at helping users get started quickly. They do that by providing a set of pre-tested and pre-configured software, which works against specific hardware and sensor combinations. And really, they are one of the aims is that they're very good for learning how EdgeX works. There's nothing better than seeing real sensor data moving through the system. You can track it as it moves through. You can perform operations on it and so on. Real sensor data. Also, you can easily sketch out and prototype proof of concepts. So you might have a project in mind where EdgeX you think can add value, but it's nice to be able to kind of verify that by doing a simple POC to start with. Then you can verify that and then transition over to real industrial devices, whether they're Modbus or OPC UA, etc. And as you'll see, there are both community and commercial DevKit options available. So let's do a quick reminder about EdgeX, as I say. So as most of you will know, EdgeX Foundry is an open source, vendor-neutral project. It's loosely coupled software framework for the IoT edge that uses a set of microservices to communicate. Microservices are usually ran on gateways, and you can kind of control which microservices are ran. They all communicate together via REST calls, typically. One of the big benefits of the EdgeX Foundry's approach is that it's hardware and OS agnostic. So, for example, you can run on ARM and x86-based gateways, different operating systems. We tend to use containers to help with that. So typically it's Docker, but that's not a requirement either. It's open source, as I said. That's Linux Foundation ran project with Apache 2 software license. And the goal of the Foundry is to enable good IoT solutions where you have a community of building blocks that people can use for their systems, but there's plenty of room for commercial value to be added. So companies such as ourselves are involved in doing that. And like I say, it's a collaborative approach where lots of companies working together to produce kind of thorough and complete solutions. So this is the quite famous platform architecture diagram that shows all the microservices communicating together. Typically, there are a set of core services, the ones in purple, that you tend to need to run, although they don't need to be all on the same gateway. But at the bottom, you've got the device services, which are services communicating directly with the real devices. As you can see, there's support for things like OPC-UA, Modbus, BACnet, etc. That's a growing list of protocols being added by the community and by commercial companies as well. But there's also, if the service you're interested in doesn't yet exist, there's a set of SDKs to enable people to produce their own device services. So there's SDKs in both C and Go that enable you to do that. So generally, the data is ingested through the device services into the core services, into the core data service in particular, where it can be stored and forwarded. You've got the command device service, which is able to send commands back down towards the devices to actually do actuation. And then you've got the help of the supporting services above that. So performing local analytics, doing schedules, alerts, notifications, and so on. And then you've also got the northbound export services. So these help you to deliver data to different infrastructures, maybe cloud infrastructures, and so on. Also, there are, on the left and right-hand sides of this diagram, there are security services and system management services. I won't cover those in this talk very much. Actually, there's a little walkthrough here for an example. So if you have data being produced from, say, a BACnet device that's recording the temperature, maybe it's 102 degrees at the moment in our room, that data is fed into the core data service where it's stored. And then it can be delivered onto the distribution service. So, for example, let's stream it to a cloud system. And then we can optionally choose to also use the data locally. So performing analytics, making decisions, reasoning on the data, and so on. So, for example, we might send a command back down, given that the temperature is 102 degrees, we might send a command back down to the MQTT device service, for example. If that's controlling the actual temperature in the room, maybe we need to stop the machine or we can actuate. Okay, so I hope that kind of makes sense as a quick walkthrough. Those microservices, contextually, there are kind of 4 different layers: device services, the core services, supporting services, and the export services. But to be more crude about it, you could consider them as a dual transformation engine. So at one level, translating information from the sensors and devices, from all the different protocols into EdgeX and normalizing that into a form that can be unified and understood by the system. And the second layer would be delivering the data to applications and enterprises that need it, maybe through cloud systems, perhaps over TCP links of the customer's choice, so actually making use of the data. So they're kind of like the broad 2 levels. So as you'll see, the DevKits are going to use all of these levels. So Grove sensors, as I said, we've initially chosen Grove as our base sensor kit. So what is Grove? So it's a fairly well-known set of sensors that runs against a base shield. It's supported on Raspberry Pi and other dev boards like that. And what you do is that you get this, you can see the mouse moving, you get this base shield which physically attaches to the Raspberry Pi, for example, by these pins, and it communicates, you communicate from the Pi onto the board via I2C, and then the individual sensors, which they're sensors for light and sound and rotary angle and so on, they all plug in via a typical 4-wire connection into these different ports. And so it's the sensors themselves are using GPIO and AIO to do the control. So we selected this Grove sensor kit because it's easy to use, it's relatively low cost and quite widely available. So what do we have to do to make this work? So we produced a new Grove device service. So that's how you integrate data into the system typically from the southbound side. So we use the C-based device service SDK, and we built the device service using the help of an open source library, libmraa, which can have support already for these Grove devices. It also requires the writing of a device profile. As you probably know, when you instantiate a device into EdgeX, you need to configure a device profile to describe how to exactly do that. And we've made the Grove device service is Dockerized as a container with a default port of 49992. So a little bit of detail about the device profiles. So as I kind of just said, the job of the device profile is to map each sensor's input and output to EdgeX variables within an EdgeX device. So in this table over here, I think this is the kind of the recommended port that each sensor is plugged into, but I don't think that's absolutely required. But the job of the profile is to map the different port numbers to the actual data type, as you'll see in a second. So there's two main approaches of doing this. The first way is perhaps the simplest, which is to have a single Grove device profile, which lists all of the resources and commands for all of the sensors in that profile. So when you instantiate the device, you have all of these sensors available to use. The second option is to have multiple profiles profile for each sensor, basically. So that gives you kind of more control, perhaps. But well, we implemented both, but we decided that the most sensible default was to have a single device named Grove device, which has all of the sensors attached to it. So option one is what we went for. That's configured within the container via the configuration tunnel and the Grove device YAML file in the res directory. But if you do want to use the multiple sensor approach, then you can do that too under the /profiles. So let's look into more detail into one of the blue LED as an example. So it says in this table, so it's a GPIO interface. I'm using port D2. So in our profile, if you've used EdgeX before, you'll recognize these profiles. So you typically put the name, the manufacturer, and then your labels at the top of the file, and then you list the device resources. So for our blue LED, what attributes does it have? So as I've said, it's port D2 of the GPIO, and it's an out configuration because it's something that we're configuring the output for. Alongside that, you've got the properties of the variable. So the fact that it's a Boolean, it's either on or off in the unit. So that's the physical mapping of how the device will communicate through EdgeX. So our service implementation will look at these values and obviously make and then make the connection. So the next level is the resource level. So we've got a set blue LED resource, which refers to that object. And then above that, you've got a command, which is how you invoke operations on that resource. So the rest command path is this, set blue LED, and the parameter that you pass it, blue LED, is the same as this one here. And that's the typical kind of responses that you expect from the rest command. So when you instantiate, or when you run the Grove device service and you use this Grove device profile, you'll get a Grove device inside EdgeX. And at that point, you can call operations. So if you would use a curl command, for example, a REST call to set the LED on, then you pass blue LED with the parameter true to the set blue LED operation defined here. So like I said, you're assuming here that we're calling directly onto the Grove device service that was running on port 49992. And also, you could specifically call onto a certain Grove device if you use device and then the device ID. But here I'm using the sort of shorthand all, so any device services will have their blue LED set by using this approach. So you can infer the rest of the profile based on this. So let's talk about using a DevKit. So, well, first of all, where do you get one from? So the community, the EdgeX website hosts both community and commercial DevKit options. As I said, the first EdgeX community version that we've just released is the Raspberry Pi 3, 64-bit version with Grove Pi sensors. So those full instructions are at this link. there's links to actually buy the hardware, the Pi and the kit itself, and this is what you get. And then there's kind of full instructions to get it running. So we've actually provided a custom 64-bit Ubuntu OS image for this, because the default Raspbian OS that you get with a Pi is usually 32-bit. So we've got a 64-bit version here, and then there's instructions to actually run the software as well. So I think, as I say, people should be aiming to validate their real use cases. So simulating real-world scenarios with these sensors that are easy to use. So this screenshot is, I think, for a page that's not quite yet live on the EdgeX Foundry website, but it lists a set of use cases where EdgeX can be applicable. So people can draw ideas from that. People working on projects in certain industries can create, these proof of concepts, collecting data from the sensors, visualizing it on the dashboards, making real decisions, ultimately proving that there's value in the project. And then once you've done that, and you're happy with the concepts, then you can perhaps evolve to using more industrial devices and start integrating Modbus and BACnet and so on. So I talk about today's demo that I'm going to show you. So I've chosen a smart factory use case. So let's imagine that I work in the smart factory industry, and I'm looking at monitoring and improving the quality of the output from my plant. So validating that the factory output meets the required QA levels. So it might be bottles, cartons, packages, any sort of thing that's output from our machinery. Perhaps we're going to monitor and analyze the size and weight of each item and verify that it meets certain thresholds. And if it doesn't, maybe we need to start controlling devices that are producing, control the actual machinery to configure the changes that are necessary. Second use case to consider is production line machine monitoring, more of a monitoring use case on the line itself. So validating that the machinery is working correctly, perhaps because we're concerned about the safety of the human operators nearby, and also trying to spot performance degradation patterns before things break. So kind of like a predictive maintenance approach. That way you can perform timely maintenance routines, for example. In that case, you want to visualize data on a dashboard and perhaps send it to a cloud system for storage and further analysis. So what does the demo do? What does this demo do? So it collects some sensor data from some of the Grove sensors using the Grove device service, and then ingests it into EdgeX through the core services. We're going to translate it into a protocol that's perhaps more human or more usable, so MQTT, for example. And then at the edge, I want to display this data and make decisions. So quite convenient. I find this is a tool called Node-RED. Most of you are probably aware of it. It's nice because it's got an easy dashboarding capability, and the way that you do kind of the visual flow programming, as I'll show you, is quite easy to use. It also has a nice MQTT subscription mechanism, and then it also supports REST calls to perform the actuation on my devices. So you can see that if I stream data to MQTT, I can then use it from Node-RED locally and make decisions. So something quite good about EdgeX is the way that you're not obliged to use any specific technology. So Node-RED is an open source tool, which we've decided to use here, but you're not obliged to use that at all. There is, capability to choose other packages as well. But for convenience, our Ubuntu image already has the MQTT Mosquito broker and Node-RED pre-installed to save you the time. So this is if we go back to our original EdgeX architecture diagram, you can see the parts that we're using here, the different layers. So the package monitoring use case is going to use the rotary angle sensor and the light sensor and 2 LEDs. The production line monitoring use case is going to use a button, a buzzer, the LCD output, and a microphone and a blue LED. I'll explain more about that shortly. So those sensors are interfacing to the Grove device service, Then the data is fed into EdgeX. We're using the distribution service to export to MQTT, and then using Node-RED to perform operations on that data. So this is that as a more physical architecture. So all of the EdgeX services are being run on the Raspberry Pi. The MQTT broker and Node-RED are also run on the Pi. I'm using my laptop here as the web browser, and the actual sensors are obviously running on the Grove hat that sits on top of the Pi. Okay, so it's time for the demo. So yes, I'm still sharing the screen. So my package monitoring dial is now at 231 kilograms. If I change this rotary sensor here, yeah, there we go. It is better. So yeah, I'm twisting this little knob to get it into the green section. So I've made the logic such that if the weight of the package denoted by this angle sensor is between 100 and 150 kilograms, then the dial will go green, and then it's considered an acceptable weight. And the package size as well is being captured. So the package size, we're using the light sensor to simulate that. So if you can imagine, as a package goes down a production line, perhaps we're taking a photograph of it, or we're recording its size in some way. So in this case, imagine that we're shining a light over it, and we're recording perhaps the shadow it's casting or something like that. So something to indicate the size. So at the moment, the size is being announced by our light sensor here, because I've got it facing away from the light. It's quite low. It's in the range of 5. So that's in our regions of acceptance here. It's between 3 and 10. So the weight is okay and the package size is okay. Therefore, the package is being accepted. And what that's doing is we're turning on the green LED every 2 seconds, if you can see that flash there. Yeah. So if I would cover up the light sensor, which should make the package size go right down, then we'll start rejecting packages, as you can see on the dashboard, and then the red LED, oops, is now flashing instead of the green one. Okay, so I hope that makes sense. Referring to the production line use case, so like I said, if we're monitoring the safety of people on the line, so maybe there's an emergency button either side of the line that people can press. At the moment, it's not being pressed, but if that's this one here, if I would press this, and we see that the button is being recorded as being pressed, and what I'm doing is sending a command to the buzzer. That's what that noise was. That's the buzzer here, which to indicate that there's a warning to the people, and also it changes the LCD output. So currently, when I've released the button, everything's okay. As I press the button and the sound comes on, then the LCD changes.
And James, that's going from the Grove sensors through EdgeX out to Node-RED and then back to EdgeX to sound the alarm, right?
Correct. That's right. Yeah, so the full stack. Yeah, that's right. And then finally the vibration, the sound vibration sensor. So there's the sound sensor, which is this one here. So this is as I speak, it'll go up and down slightly. At the moment, we're hovering around 15, whatever it is on the scale. If I change the acceptance level to make it safer, then the line's operating normally. If it would go cause an issue, then okay, we need to send an engineer. That's being recorded, and we're sending a blue. The blue LED turns on at that point. So I hope people can kind of see what we're trying to do here. It's using the sensors, making decisions at the edge to kind of replicate a real use case. So once I'm happy with my logic, I can now think about using, let's measure the weight with actually a real set of scales, for example, a real kind of industrial device. So I can do that instead. I can use a different device service. Maybe there's a Modbus service that I can use, or maybe I need to write another service using the SDK. But you can switch the devices out, but crucially keep the same business logic in place. So the same Node-RED dashboard here would work whether it's these Grove sensors or sensors from something else. So I think that's quite nice. So let me stop sharing on my phone, and I'll quickly show you a couple of things on Node-RED itself. So this is my flows diagram. So in Node-RED, you use a set of flows to perform the programming. Like I said, it's quite visual and easy to use. So I've got an MQTT subscription node here. So if I quickly double-click this, you configure the server. So that's the IP address of the Raspberry Pi and the port of which Mosquito is running. And then you configure the topic name. So my export, which is a script as well that's running. I'll make all this available, by the way. I'll put these flows and the necessary scripts. In fact, the necessary scripts are already on the EdgeX community website in the DevKits area, but I'll also make the flows available. So the name of the topic that we're exporting is called MQTT device Grove. And from then, we need to do a little bit of work to convert into JSON. And then I've got the four states that are being pulled from my different sensors. So for example, in here, some simple programming that looks for the rotary angle data, parses it into a valid number, and then I can set that as a variable in my Node-RED. So the rotary angle is then set there, and you just join these together. So if you want to do a graph, you just join that together, and that feed then outputs to the package weight graph. So you just construct all these like this. If I was to do REST calls to actually actuate on, so you can see this happening here. It triggers every 2 seconds. So, for example, the logic for the buzzer is quite simple. If the button state, we get the button state here, and then basically if it's set, and we set the Grove buzzer parameter with the string true, and then we stringify that and pass that as a message payload, which goes on to the next flow, which is the REST call. So I've got hard-coded paths in here for simplicity. To set the buzzer on that port, as I showed already in the slides. And then a little bit of logic. So this is a 2-second trigger. So every 2 seconds, I'm basically making a decision based on the current state of what I'm seeing for all these variables. I'll make a decision as to what the output should be. So that's not a very good one to show. So analyzing the package, for example, pretty simple. It's JavaScript code you write. If the rotary angle, like I said, is greater than 100 and less than 150, and the light intensity is acceptable between our minimum and maximum range, then we kind of accept it, and we set the variables necessary for that. And if not, well, then we reject it. And you continue to the next flow, which will in turn actuate the green and red LEDs and update our output on the screen. So, it took me only, let's say, a day or so to put this together. So it's relatively low cost in terms of effort to get something quite good working. So let me switch back to the slides.
Can I ask you a question? Sounds like two of us have a question for you.
Go on, yep.
So this is Randy Thompson. Yeah. You used Node-RED in this case because it was more visual, and it gave you a tool that you could show getting data out of EdgeX and then sending a command back again. But you could have also used the rules engine or the rule service that's available within EdgeX, right?
That's true. So there's the rules engine at the moment. I think it's Drools, which is Java. So I think the EdgeX community are looking for perhaps a Go-based alternative to that as a default. But yeah, I could have used that. But I quite like Node-RED because it has a dashboard associated with it as well. And it's easy to use. I knew how to use it. So it's my own preference.
Okay, no problem. That was the clarification I was looking for.
But yeah, you're absolutely right. There's no reason why you couldn't use that, and you can use anything. That's the beauty of EdgeX, is that you can plug in different components for different jobs.
All right, thanks.
Was there another question from somebody? No? Okay, so if I carry on. So just a couple of slides to finish on. I'll switch this around. So that hopefully is an indication of the type of thing that a DevKit can do. In the future, there's going to be more DevKits for different environments, for different development boards, and supporting different types of sensors. So Grove is just one set of sensors. In fact, Grove itself, there are dozens of different sensors that can work. I think right now we support the sensors that come with the Grove Pi starter kit, but like I say, there's dozens of other ones. So if people are interested, they can. So obviously this is an open source effort, the Grove device service, so people can add new functions to support. For example, I think there's a laser sensor and a water sensor and other things like this can be supported. But what I guess I'm hoping for is that we have more use cases come forward. People kind of promote ideas. People can create their own node flows or Drools flows and so on to make this happen. And we're going to be looking at doing certainly blogs and more videos and tutorials to help push this out a bit further. So normally, I think people finish on the project link. So this is the same as normal, but I've added in an EdgeX DevKits link for people to use there. So
actually,
I think
James,
there's a few minutes left for questions.
James, could you go back a couple of slides?
Sure. Which slide? This one?
Yeah, that one. So we're trying to put together a directory listing of DevKits and projects related to DevKits. Right now, we've got the community one that James just demonstrated, and IoTech has a few others that are also based on Raspberry Pi and Intel board. So we're asking all of our members to submit any kind of kits or projects that they have that we can promote EdgeX as a platform for people to get started prototyping with. So you can use the Ubuntu image that is being provided by IoTech, which does come with the EdgeX core services running in Docker and also Node-RED, and then build something on top of that if you want to add your own device service or you want to add your own application side or AI analytics, anything like that. Or you've got a specific project like Intel's got IP cameras that they're working on that I've asked them to submit also through this. So anything that you're working on that you think would be generally useful for people who are trying to prototype a solution to a specific use case, submit them to this Google form link that I posted in the chat, and that will go to Brett, and he will turn that information into a listing on this website so that we can get this published and advertise all of the work that everybody's doing. All right, that was all I wanted, James. You can go back to the Q&A. Yep.
That's good. Is there any questions from anybody else on the call?
There's a question from Marcelo in the chat. He's asking if there are any plans for device service for particle boards. And I guess that's a specific, maybe sensor board.
I can't see the chat, actually, but where is it? Oh, I see. Particle boards. I'm not sure of any plans specifically for that. I can find out, certainly. I think, well, certainly we're aiming for not just the Grove and the Pi sensors to be supported, certainly different ones. So I'll look at that particle boards.
So the EdgeX project right now is only focused on this one community dev kit that was really meant to bootstrap the DevKit program. Like I said, we're hoping all of our members start contributing their own. So if you're working on particle boards with EdgeX, then I would recommend you send that in as your DevKit submission.
Yeah, this is Marcelo, and thank you for all the information. Currently, I am working on particle, and I just was starting, so I just wanted to make sure that embossing is not being done yet. So I will try to work on that, and if I am successful, I will definitely post it.
That'd be great. Yeah, really good.
And we also have a DevKits channel on our EdgeX Foundry Slack. So if you're in there, you can join the channel and you can reach out to us there. And I can give you the link to submit it anytime from there.
Okay.
Oh, great.
So that's where I'll put the flows of this demo as well for people to use.
Yeah, thank you.
Any other questions for James about DevKits? All right, well, hearing none, we will go ahead and wrap up this tech talk. Thank you, everybody, for coming and for your questions. And big thank you to James for putting on this presentation for us and doing all the work that you've done on the DevKits in general.
Okay, thanks. That's fine.
This video will be available to rewatch. I'll put the link on the wiki as soon as it's available, and then you can share that around to anybody else who you think might be interested in this. Okay,
all right.
Thank you for coming, everybody.
Thanks, Michael. Yeah, thank you.